Okay, so I want to talk about linear programming, which a lot of you probably know under its maybe more realistic pseudonym as optimization. This is not your Calc 1 optimization technique set, okay? Calc 1 optimization techniques don't work on this stuff. Even Calc 3 optimization techniques are a little bit different, not necessarily weaker, but just different, okay?
Good.
So whatever you know about optimization, forget it now. No, wait, we'll do some other stuff. For those of you who have had some optimization, what's the point? Like, what kind of problem do I solve by optimizing?
How do you maximize your profits? You pointed to me.
Yeah, I did. So what I want for you guys to think about optimization and the point of linear programming is this kind of maximize or minimize your whatevers. So that would be things like maximize your pay, maximize your productivity, minimize your expense, minimize the amount of time you spend wading through water, stuff like this. Cool? Yeah, you always want to minimize the amount of time you spend up to your knees in water. Always good fun. Okay. So to do this, I need to give you some things. The first one is this little theorem, which is the Fundamental Theorem. No. So there's a bunch of fundamental theorems, and the subject that we're studying today is
Linear programming.
Linear programming. So this is going to be the fundamental theorem of linear programming. Okay? There are lots of fundamental theorems. This was a new one on me. It's not particularly hard to believe. It does have this little caveat to it that your book does not mention. And the reason I'm bringing this up is that we have some of you have had more advanced or different optimization techniques. So I need to say this because otherwise it's not going to be true. So all things being linear,
That eliminates a lot.
yeah. So this takes you from a different place, right? So normally when you do calculus style optimization, everything's smooth. Smooth is out the window here, but everything has to be flat. Okay, so all things have to be linear. Then, and this is going to sound weird because we don't have these words yet, but trust me. Then the max or min occurs at a vertex of the, how do you spell this word? Feasibility Polygon. And I know you don't know what a feasibility polygon is. Cool? So believe me, there's such a thing as a feasibility polygon. And the important thing here is just this. You're going to have to check the vertices. Cool. I know, it doesn't make any sense right now. It's totally okay. Is your question what a vertex is?
I know vertices, and then I thought maybe that means more than one vertex.
Good. Okay, so I don't know what a feasibility polygon is, but here's a polygon. Let's assume it's a feasibility polygon. Okay, and what this statement means is that somehow these things, right, each of the vertexes is going to be important to me. Because I'm going to just check them all and see where the maximum or minimum is. Does that make sense? You need an example. Okay, let's make an example.
So inside's always